Morning, ladies and gentlemen. I think that was a very inspiring start this morning to set the scene for us. And of course, the last weekend as well as Monday has been quite active in the UN discussions regarding the actions that we must take. But I've got some leaders who are very technology focused in terms of developing ocean renewable energy, and I'm really delighted to have them here to present to you and hopefully make some controversial remarks so that we can all pick up and have a little bit of an argument about it during today. The way I think we would do is that Pedro, I won't introduce each of them because I think there is a detailed bio for all of them. And they are industry leaders, so I think they're pretty well known. Pedro I've known for a long time with WavEC anyway. So firstly, Pedro, manager of Clean Energy Group at EDP, will in fact make the first statement regarding offshore energy growth opportunity. Can I ask Pedro to present? Thanks.
So good morning, everyone. Before I start, I would like to thank you, Wave Energy Center, for co-organizing this with the British Embassy. It's a pleasure for us to be here as a speaker and also as an attendee. So the presentation that I have today is about our activities on offshore wind, and I'm going mostly to focus on floating offshore wind and why do we consider this as a growth opportunity. Before I start into the topic, I think most of you already know EDP, but it's always interesting for the ones that are from abroad to have a better view from what is our company. So EDP is an international company. We are co-located in more than 16 countries. Most of the countries we are developing renewable energy, and this is one of our main growth areas. We have more than 12 million clients, and our EBITDA it's more than 4 billion euros. So we are a big international company. Key important figures from our renewable activity. We are a renewable energy leader with more than 11 gigawatts capacity of onshore wind installed. Most of our capacity is co-located in Europe and the US, and we are also have a big pipeline in Brazil. Also to mention that this is one of our main growth areas, mostly with a huge pipeline in US, and this is one of the drivers for our growth of our company. Now getting into offshore wind. Currently, we are developing, we still have a big pipeline in offshore wind. Mostly they are located in UK and in France. In UK, we have two projects. It's Moray East and Moray West. Each of the projects has around 1 gigawatt capacity. Currently, we are developing one of them, which is Moray East. Construction is starting this year. And we have already granted a price of a CFD award of 57 pounds per megawatt hour. The second area in UK, it's Moray West. And Moray West, we are still developing and trying to lease the site. And we are planning to develop this during the next years to have the project in construction in around 2020. In France, we do also have two projects. They are a bit smaller. Each of the projects, they have around 500 megawatts. It's the Tréport and Noirmoutier. These projects are already ongoing and they are going to be implemented and installed in the next couple of years. Now, going to the floating area, which is one of our main activities, and we see this as a strategic view for our company. Why did we start with this venture? Why were we the first ones to try to engage in this new technology? We saw this opportunity in collaboration with WavEC Center that presented us this technology. We saw this as a strategic vision for our company because we wanted to open a new market. We wanted to anticipate the trend of the market. We wanted to have a new opportunity to grow. This is the reason why we started investing in this technology, and we started to do a pilot project in 2011 in collaboration with some of the companies that are here today. In parallel, we also engaged with Principal Power, which is a key technology developer for this project. And also to show that this is strategic for us, we are also investor on Principal Power with some equity in the company. So we see this very seriously. When we engaged in this project in 2007, this was not on the agenda of the industry. Now, 10 years after, this is already in the agenda, and everyone believes that this is possible. So this is very good for us, and we are very proud of it. We didn't do this alone. We did this with all the companies that are here with us, local companies and international companies. So we still have some way to go to reach a commercial technology, but we are getting there. So currently we have several projects ongoing. We did the prototype that was installed between 2011 and 2016, operated for more than 5 years. And following that, we have 3 other projects ongoing, which is the Wind Float Atlantic that Rubaneiras already spoke about it. We have a project in France, in the Mediterranean, and the last one is in the US coast. So getting into the details, why and how do we bring this technology to a commercial stage? There are 3 key pillars that we need to demonstrate when developing a technology, and especially a technology like this, which is capital intensive. So the first item that we need to demonstrate is technology. So we need to prove the technology. We need to demonstrate that technology is viable and de-risk the technology. We have done that with the Wind Float 1. Second item is to demonstrate that the cost of energy can be competitive with other technologies. And this is a path that we are following. There is a clear roadmap on the technology development to achieve competitiveness and I'll say competitive and cost of energy. And the last item, which is being developed in parallel with the reduction of cost, is bankability. So we need to demonstrate that although we have a low cost of energy, the technology works, this technology is bankable, so we can lend money to develop this. So this is the path that we are trying to follow with the projects that we did and are doing. Wind Float 1, the prototype operated, like I mentioned, for more than 5 years, installed in the north of Portugal. And this technology allowed us to demonstrate that technology can survive. It operates as expected. And more than that, we were able to demonstrate that the models that are behind, they were accurate. So that gives us extra confidence to pursue a new development of technologies. Also to mention that one of the key features of this technology is that we can control the risk and the cost. That is mostly done by doing most of the work onshore, very few offshore, and we clearly demonstrated that during this venture, this prototype that we developed a few years ago. Also, the decommissioning, it was also that we did in 2016, and that was very key also to demonstrate that we can decommission this safely with very few means, cost efficient, and very low risk. So going into the wind float Atlantic, this is the second phase of the wind float. It's a pre-commercial technology or pre-commercial project where we are installing 3 devices with 8 megawatt turbine in the north of Portugal, Viana do Castelo. The plan is to have this in operation during 2019, so by the end of the year this is going to be already in operation. And one of the purpose of this project is to be able to demonstrate that we can reduce the costs, incorporate some learnings from the previous project, and also demonstrate that the industry is capable to build several units. And we are seeing that with our partners here in Portugal and as well in Spain. So that is going to be a key learning for us. The second project that EDP is involved is a project in France, in the zone of Leucate. It's in the Mediterranean, in Gulf de Lyon. And this is again another pre-commercial project that we are doing in partnership with other parties like Engie and Caisse de Dépôt, which is a bank from public bank from France. And clearly here our message is again to deliver the project, incorporate new innovations to the technology, try to drive the cost down, and also developed a key supply chain that is important for us to develop this technology. So this project is planned to be operational by 2021. Currently we are on the engineering phase. The FID, so the final investment decision for this project, it's planned to be next year. There is still plenty of work to do. Like Ruben said in his speech, we here are very well focused in trying to gather local stakeholders engagement. So we are doing significant work on that front because that's very key to the success of the project. And this is something that clearly we need to address very seriously because they are the key stakeholders for these projects. And the last one, and this is my last slide, this is a project that we are co-developing as well with Principal Power and Aker Solutions in the west coast of US. This is a bigger project, so this is 150 megawatts project with 10-15 turbines with more than 8 megawatt per turbine. So we are now looking bigger. With all the projects that we are doing previously, we have de-risked the technology. Now we are increasing the size, the scale, and we really want to reach commercial solutions by 2020, 2025. So this is a private-public partnership with the local community. We are still, although we have been awarded in their request for quotations, we have been awarded, and now currently we are working to lease the site. So we are still in an early stage. This is greenfield work that we are doing. So basically, you can see throughout these all projects that we have that clearly we have a vision that floating wind it's important for us, and it's something that we believe, and it's a a possibility to continue growing the company and diversifying our portfolio. So basically this is what I had to tell you. If you have any questions about this project, let me know. Thank you very much.
Thank you, Pedro, for that very good overview of your activities. I wonder whether people have any questions for Pedro. Antonio. Do you need the microphone? I can throw this. You're getting one.
Yes, Pedro, thank you for the presentation. Now, I have, well, 2 or 3 questions. One, first, well, they are related. The first one is, what is the cost reduction that you expect from the 3 set of projects? So Windfloat 1, Windfloat Atlantic, the one in France, and the one in the US. What are the cost reductions that you expect, and what are the main factors that affect this cost reduction? So this is one question. The second one is to know whether there is any plans to expand the Windfloat Atlantic project here in Portugal.
Yeah, it's working. So clearly our vision is to drive the cost down throughout all the projects. Windfloat 1 was a prototype, so it's not a reference. Windfloat Atlantic currently it's an improvement from the Windfloat 1, where we still are developing and trying to engage with the industry to try to drive the cost down. We have achieved, I will believe that Windfloat Atlantic for the first pre-commercial stage, it's competitive. So it's a small-scale project, but everyone knows, it's public information, that the feed-in tariff is around 168 euros per megawatt hour. So we drove the cost down. In France, we are also trying to drive the cost down. It's still a smaller project, so we cannot incorporate all the levels to reduce the cost. We are doing several technology innovations, like new ways to fabricate the floater using different type of steel, and that will simplify the fabrication process, although we are still talking about a small-scale project, so we'll be more or less in the same range of costs as the Windfloat Atlantic. So we cannot, with such a small project, and in fact we are using smaller turbines, 6 megawatt turbines, which is not so cost efficient as the Windfloat Atlantic, where we are using 8 megawatt. So the cost, it's around the same figure, so close to 200 euros per megawatt hour. But for the project in UK, for the project in US, sorry, that is a much larger project. So there, we believe, and we still have to confirm this because we are still in a very early stage, but we believe that will be close to 100 euros per megawatt hour. Mostly there, we are going to incorporate all the technology innovations that we can at that stage, but mostly what is going to drive the cost down is the scale, because we can dilute all the fixed costs among lots of units. So basically those are the levers. There are technology innovations. We need to work very closely with our industrial manufacturers or our industrial partners, also to design the structure in a way that is the most efficient to fabricate. And then the last is scaling. Hope I have answered your question.
Very well, actually.
Well, in the end, our target, I think this is important. In the end, our target is to reach 50 euros per megawatt hour. So that's where we want to get. there is some time to get there, but we believe that by 2030 or even before that, we will be able to reach those figures with large-scale projects. So we really want to be competitive. We want to reach grid parity, and we want to be able to match the cost of the other projects as well.
Very good. Thank you. Any other questions? I think we could try to take some at the end because we are also running out of time. So can I ask Aaron to give his presentation on wind float?
All right. Good morning, everyone, and thank you for having me here today. I think I'd just like to begin by thanking WavEC for organizing this and being a partner. It's been about 10 years since WavEC and Principal Power have started working together, and I think it's been a very good partnership. So thank you again. And then also just a big thanks to the Ministry of the Sea and the entire Portuguese government for providing championship around marine renewables and floating wind in particular, and giving Principal Power a space to prove the technology and start the development leading to a marine cluster here. I'll talk a bit from Pedro's very nice presentation about the different activities and projects that we're involved in into kind of where we see the market going and how we see floating wind as essential for globalizing offshore wind. First, a small introduction to Principal Power. So we were founded in 2007. We have about 60 people now with offices in California, France, and here in Portugal, where we have about 10 to 15 people or so, still adding people as we speak. We have a very strong backing of power utilities, oil and gas contractors, including the EDP Group and Matos, which is in the audience today, as well as technology partnerships with Shell and InnoEnergy, which is a European Innovation Fund. Our technology is the wind float. We provide services and technology around this platform, and basically we here in Portugal proved that this technology works, generating about 17 gigawatt hours of energy over a 5-year period and surviving waves up to 17 meters, really fully proving the technology and that it works according to industry standard power curves, allowing us to move to the next phase. Right now we have a project pipeline that includes about 100 megawatts of projects that are in various stages of execution. And we are in parallel developing a large commercial pipeline of projects in Europe, the US, and Asia. Our vision is to be the global leader in floating offshore wind, and basically we want to make sure that the wind float as a technology platform can be the most safe, competitive, and economic offshore or deepwater offshore wind technology, allowing us to unlock gigawatts of renewable energy worldwide. Just a brief overview of where we are right now in terms of the offshore wind industry. So right now we're seeing a move to bigger projects. That means we're going above 600 megawatts to some projects are even in the range of 1.4 gigawatts. Big clusters equals economies of scale, much greater efficiencies during construction and operations. We're going to larger turbines, so the biggest turbine on the market right now just crested 10 megawatts, and we have turbine manufacturers with machines up to 15 or 16 megawatts on the drawing board. And projects are generally being located further from shore in deeper waters, which makes them generally more technically challenging. Despite that, we've seen through this progress on technology, on commercial terms, on financial acceptance and risk reduction, we've seen a drastic reduction in the amount of subsidies required, and now we even have some projects that are scheduled to come online in the early part of the next decade that will not require subsidies. So offshore wind is becoming subsidy-free, and we think this is very important to recognize. That said, to date, the offshore wind industry has been a very regional industry. We've been limited to Northern Europe, North Sea, where the sea is quite shallow, and the Chinese market is picking up quite a bit. We're starting to see some acceleration into new markets like the east coast of the US, Taiwan, some shallower areas of Japan and Korea, and some in India as well. But generally, the markets for offshore wind are still quite limited, and really those limitations come down to depth and seabed. In order to basically overcome these limitations, the industry took its first steps about 10 years ago towards developing floating wind technology that is decoupled from the seabed and basically would allow you to deploy in water depths over 1,000 meters deep. And the first steps were the Hywind project in Norway from Equinor and the Windfloat Atlantic project, which was installed off of Gusadora in Portugal. These both proved that the technology worked and allowed us to move to what is really a new phase for the industry, with Equinor installing the 30 megawatt Buchan Deep project in Scotland last year, where it's operated for over a year, posting very high capacity factors and proving that floating offshore wind can perform just as well as fixed bottom offshore wind. And also our Windfloat Atlantic project, which is under construction by Asavomatos in the Ližnav shipyard, just about 30-minute drive south of here right now, and will be installed next year. That'll use 8.4 megawatt turbines from MHI Vestas, which were basically the largest turbines commercially available when we signed the purchase order. And that'll be installed in 2019. And then the next project, which is really exciting, is the Kincardine project in Scotland. And this is basically a project where we installed the original Windfloat 1 unit. We retrofitted it in coordination with Asavomatos this summer, brought it to Scotland and installed it offshore there to secure an opportunity to, in 2020, deploy 5 9.5 megawatt wind turbines from MHI Vestas. So that'll be a 50 megawatt wind farm. It'll be the largest floating wind farm in the world when it's installed, and a key milestone for the industry. I think from Pedro's presentation, one of the most key findings or milestones was basically the close of finance of Windfloat Atlantic with the EIB, which really proves that floating offshore wind is bankable. It can pass technical and commercial due diligence. Banks are comfortable with it, and that we see will unlock the industry for the next phase, and really proves that that we can move to the development of large-scale commercial projects. Basically, having gone through this pathway of developing, deploying, and proving the prototype, then moving on to proving the economics and bankability at these 3 pre-commercial projects throughout Europe, we feel that we're very ready to move to the next stage, which is an industrial stage, where we're developing projects of between 10 and 100 units in different locations around the world. And here what we're doing is we're focusing on the largest next generation turbines. So we're working with Senvion on their new 12 plus megawatt machine through an H2020 funded project. We're working in the EFGL project in France, as Pedro mentioned, on some key innovations to go from the second generation that will be deployed at Windfloat Atlantic to a third generation that will be much more easy to fabricate, modular, and ready for serial production. These trends combined basically show that we can plug into the technology and commercial innovations of the fixed bottom offshore wind industry and deliver projects that by the mid-2020s should be able to deliver in parity. And we're seeing that major sponsors are recognizing this confluence of trends with competitive technology and floating offshore wind making deep water sites viable. We have basically the majority of the sponsors in the industry are now starting to take positions in floating offshore wind projects, and we've documented over 16 gigawatts of projects that are now under development globally, which is a huge milestone. So basically the lesson for today is that when you have commercial, viable, deep water offshore wind, you can open all of these markets worldwide to floating offshore wind, and it can go from a regional industry to a global industry and make major contributions to our overall society goals to decarbonize the economy and boost marine industries. I think it's always helpful to look backwards in time to see where we were, where we thought we'd be, and where we came to. So basically 2007 was just when I came out of school, came into the onshore wind industry, and at that time we had about 100 gigawatts installed, and there was a projection that we would add to go to about, It's good when you forget that you removed your animations. Excuse me. So basically, let's see, does this have a pointer? It does. So basically, we were projecting to go to about 300 gigawatts from a base of 100 gigawatts in 2007. And what the industry actually did is we more than doubled the expectations and added about 700 gigawatts. And that's for a number of reasons. It's because we developed new technology which made sites more accessible. It's because the cost came down and different things like this. In the offshore wind industry, we are currently at about 20 gigawatts right here, and we're projected to go to somewhere between 115 and 130 gigawatts by 2030. That said, we think that floating can open new sites in a way that is economic and competitive and can really boost our growth. So that's kind of our vision for the industry, and thank you very much. Look forward to your questions.
Thank you very much, Aaron. Any questions? Okay, there's one there.
Thanks for a really interesting presentation. I was just wondering if there's any kind of significant financial hurdles that need to be overcome in some of these more emerging markets in terms of like port infrastructure and supply chain capability that wouldn't necessarily be there if they don't have an existing offshore wind or potentially oil and gas market.
Yeah, absolutely. I mean, I think that's one of the most interesting things about the question that Professor Samanto asked Pedro was, what are the economics in these different markets? And when you look at the markets that we're active in right now with Portugal, France, and the west coast of the US, you're looking at markets that don't have that sort of established infrastructure. And so we do have a much higher hurdle from an economic perspective to reduce costs to the sort of levels that we would see if we were to build a floating wind project in the North Sea. I think that right now what we're doing in our projects is we're really trying to minimize the amount of infrastructure investment that is required to actually build the units because they can't support a huge new investment. However, as we move to really commercial scale opportunities and as we start to see the global pipeline increase and build confidence, we see those facilities as having the potential to emerge and become very competitive for Europe as even an export market. One of the things that I look to, which I think is very interesting, is basically there is a project in Taiwan. I think it's a Macquarie-led project, and in fact it will be sourcing monopiles from, I think, the Netherlands, right? So when you build those sort of supply chains, when you create the platform from growth by committing to volume and visibility for an industry, you can make those investments in the supply chain and catch up quite quickly.
Very good. Any other questions? Okay, Antonio.
Well, my question has to do with the technology, whether in the future there will be, you expect to have any change in the concept, and at the same time, how do you look into competitors that are developing technologies or platforms with a similar basis? So how do you, what is your strategy in terms of, say, differentiating from this, or do you believe that your technology is so good that you don't have to, to fear anything from them?
No, it's a great question. It's one we ask ourselves all the time. And first, I'll say that the fact that there are all these competitors in the market is a very good and healthy thing. It means that basically it's not just Principal Power and Equinor that see a massive market potential for these sort of solutions. It is something that, there's over 40 concepts under development. But then to answer your question more specifically about ourselves and how we view the technology, if you go from WindFloat 1 to WindFloat Atlantic, they look very similar on the outside, very, very different in terms of how it comes together. If you look at WindFloat Atlantic and you look at the EFGL project, again, it's very, very different. There are reasons for that. We've been able to experiment both in the physical world, in wave tanks, and numerically to understand what works and what doesn't work. We think that those learnings are keeping us ahead of the curve of our competitors, who many of them are still trying to understand if their technologies will work in the actual real world environment. And I mean, I think we just stand on the basis of these relationships we're building with customers and an ability to continue to revisit the concept and innovate. Now, do we think that we'll move away from a 3-column semi-submersible that uses active ballast and heat plates? Probably not. We think that technology it's light, it's suitable for modular fabrication, it performs very well, and so I don't think we see a huge impetus to change that.
If there are no questions, I've got one for both of you, probably, for Pedro and for Aaron, and that's there is this arms race for turbine size, yet on a kind of fundamental way, the bigger they are, the less efficient they are, because effectively it's a cubic increase in cost while square increase in energy, energy capture. So my question is there a time that's going to come when, particularly maybe driven by the cost reduction needs of floating, that we might have multi-rotor structures, or are these still pie in the sky?
You took a twist there that I didn't expect. I mean, first, in terms of your first comment about the lower efficiency from a physical perspective of larger wind turbines, I used to work at the National Renewable Energy Lab, and we always would look at this, and basically we were looking at these old data, and then there would always be these disruptive technology trends that would allow you to kind of break that mold a bit. And I think the interesting thing about the cost reduction trajectory that we've seen here is that going from a 4-megawatt turbine in 2008 to a 8-9-megawatt turbine today, you've seen the cost per megawatt half. And that's on the turbine side of things. It's partially due to commercial pressure with larger, more competitive competition, but it's also due to industrialization effects and technology progress that are kind of counteracting some of those scaling trends. So far we haven't actually seen physical evidence of those trends being a barrier to the scaling of turbines. Second, in terms of multi-rotor platforms, I think what we see and what we're focused on is a proven powertrain, right? That's how we feel that as a small niche part of the industry right now, we can get the intention of turbine manufacturers, and the confidence of developers is working with the turbines that are available on the market today. As we go to the 15-megawatt turbines that are on the drawing board, we see just tremendous benefits in terms of the wind float, which now is around 300 tons per megawatt, and is basically has the potential to go to 150 or 200 tons per megawatt as we are at these larger turbine sizes. So we're ultimately not going to be the ones that determine the limits on turbine size. It's going to be the turbine manufacturers and our customers, and we'll work with whatever is considered to be bankable and commercially viable.
Pedro?
Just to add on what Aaron said, in fact, you were saying that the bigger the turbine, the less efficient, but in this case, in the floating, it makes a huge difference between having a 6 or 8 megawatts, because the platform does not scale in the same proportion, so you are saving still and increasing the amount of energy that you can produce. So that in our case is driving to a more efficient design, to a more efficient platform, because I'll say more or less for the same cost we can produce much more. So I think that's a key important, and I won't say the bigger the better. There is going to be a limit there, but at this stage what we see is we can definitely increase the size of the turbine with clear benefits on the costs. So that's important.
And just one more thing there, because I think it's just interesting from a technology perspective, is that what Pedro says is very true. But when we go to a market like Japan, where the wind speeds are much lower, and we try to deploy a wind turbine that's designed for a ripping wind speed site in the North Sea of 10 meters per second, we actually see sometimes that a 6-megawatt turbine with a lower specific power is more competitive than an 8 or a 9.5 megawatt turbine that's designed for those North Sea sites. So what I would really like to see from the wind turbine industry, and not sure if there's anyone representing that here today, but even the research community is looking at how low wind speed offshore wind turbines can really expand the markets and make offshore wind a more competitive source of energy in those areas that has lower wind speeds. We saw that in land-based wind, and I think it's a very important trend for the next 10 years in offshore.
Very good. Okay, I think we should press on to the next speaker. Thank you very much. The next speaker is David Langston, who is Program Manager at WavEC Scotland. So a slight change of tack remaining within offshore renewable energy.
Firstly, I'd like to thank WavEC for organising this seminar and inviting me here today. Different subject area, obviously waves, and waves move up and down, and so have the fortunes of the wave energy industry over the years. In fact, it was moving down when I started my first job, which was in 1979, working for a small engineering consultancy in North London, working on components of the Salter's Nodding Duck. And that was just before the UK government withdrew funding for the wave energy programme. So I then moved into offshore oil and gas and the power industry, but went back into wave in 1999 when I joined WaveGen. And at that stage, things started to pick up. Utilities started to get interested in the area. OEMs started to move in. In fact, Voigt bought WaveGen. A few years later, I moved on to marine current turbines, and Siemens, another large German OEM, bought marine current turbines. So things were on the up. At this time, the Scottish Government were investing significant sums of money in wave in Scotland. And before this wave was breaking, they decided to look in detail as to what was the main important area to concentrate their efforts. And that was technology. And that's why WavEC Scotland was born. And shortly after WavEC Scotland started, Polaris failed. And in fact, WavEC Scotland bought the company from the administrator. And then shortly after that, Aquamarine Power ceased operating, and WavEC Scotland bought the intellectual property from the administrator. So that's really the background. WavEC Scotland is funded by the Scottish Government, and we concentrate on developing technology, and we use an innovative process to do that, to reduce the risks and take it as a step-by-step process. Currently we have 177 organisations that we're working with, but that's probably going to increase very shortly. To date, we've committed just over £30 million. Again, that's going to increase very shortly. And we've placed 84 contracts for research and development. And we have companies from 13 different countries in the programs. So we have currently 4 programs: power takeoff, wave energy converters, structural materials, and control systems. I'll just give you a brief overview of those programs and how they work. So firstly, we use structured innovation, and we use what's called pre-commercial procurement, which enables us to fund up to 100% of the cost of the R&D contracts. It starts at phase 0, which is where we carry out a landscaping study to look at the status of the industry and identify where there are potential areas that we should be investing. We then design a program, and we go out we advertise that through the official journal, so it's open to all European companies. We select the best technologies to enter into phase 1. And that selection process is not just carried out by us, we also employ external experts, which we also procured through an open process, and they help us with that selection process. So there could be up to 13 companies. In fact, we've had 13 companies in one stage at a time. So they enter into phase one. At the end of phase one, when they've completed the work, we carry out a stage gate competition, and we select the best technologies to move through to phase two. So phase one is really concept characterization and refinement. Phase two is concept optimization, front-end engineering design, ready for phase three. At the end of phase two, we carry out another competition and select companies to move into the third and final phase, which is small prototype development. So this is the power takeoff. This shows you the different areas from dielectric generators to polymer springs, so different types of power takeoff. That have all these have been R&D projects within our program. So there were 17 in total, 17 different technologies in the program. And this is where we are today with five technologies at stage three, or just having completed stage three. Give you a quick overview of some of those. We've got Artemis working with Quotient with their digitized displacement hydraulic power takeoff. And we've got Ecos, who have recently been acquired by Oceaneering with their magnetic gearbox. And this has the advantage that if the gears slip, then there's no physical grinding of teeth, it's just magnets that are slipping. And then we've got Umbra, an Italian aerospace company, with their ball screw. This is a picture of the tank, it's just about to be filled up with simulated seawater. And that whole package is shortly going to move to Orkney to be tested offshore. And on the right, we've got the University of Edinburgh with their linear power takeoff, linear generator. And Core Power, who are here today, with their high drive as a rack and pinion device, which was tested at the nursery site in Orkney. So on the Wave Energy device program, we have 4 contractors at stage 2, and they're currently in a stage gate. So we will be announcing the Happy 2 contractors that will move through to stage 3 next week. So we've got AWS with Advanced Wave Swing, it's a submerged buoy. We've got 4C working with Sea Power, which is an articulated raft. We've got Motion, have been using genetic algorithms to optimize the shape for a raft. And also Checkmate with a bulge tube, which is a rubber tube to produce energy. We've got a materials program, and that's now at stage 2, and we have 3 contractors now. We've got Netboy, we've got Arup working with Cruise Atchison, who are now K2 management, on a concrete solution, and Core Power working with Balmoral on a composite solution for making the hulls. Controls. The problem with controls is trying to get a graphic that looks good, and I'm going to concentrate on trying to get something a bit better than just a load of words. But the controls, we had 13 at stage 1. This is stage 2, and there's some really interesting. I mean, it's been one of those potential areas that people have hoped could double power output from devices, and certainly there's some really interesting things going on here, and we'll shortly be seeing how that. Actually test those and see how those control systems perform. So we are carrying out just completed some landscaping projects which could turn into future programs, and we will be launching the results of these 4 landscaping studies this week, in fact at our conference, which is on Thursday in Edinburgh. And we have a WavEC library, so we issue a lot of information. And it's one of the conditions of the EU is that we have to publish information that comes out of the R&D programs, and this is how we do it. So feel welcome to join the WavEC library and find out a bit more about what's actually going on and some details of the contracts. And we also provide information from some of the other companies which were funded previously by the Scottish Government, for example, Polamis and Aquamarine Power. So you can find out a lot of detailed information about those, the technology that we actually own. So, thank you very much.
Yeah, I'll come to you next.
Well, I think I have two questions. The first one is whether you are looking into having some kind of partnership with other programs or programs in other countries to work together so that you really start having something at a different scale, because you may increase the amount of money available to develop a technology that we know that it's very challenging. And the second one is, if I understood well, your interest is, or to some extent, at least as I see it, up to a given point in history, and that's where I think when you come up, wave energy technologies were developed looking into the entire system. So a company would be looking into developing an entire system, which is very complex, because there are too many innovations that you need to integrate, and the complexity is maybe beyond what a single company can do. So to some extent, if I understand well, your challenge is to be able to pick up components from, say, different companies and somehow integrate them once they are developed in a system which possibly will not be owned by a single company. Could you please comment on this?
On the first point, we are working with several other organizations, including the DOE in the US, and we're working on various European programs, including DT Ocean Plus. And the European Union has announced that there will be a European-funded version of pre-commercial procurement. And we're working with a number of different member states on designing the same system, but on a European basis. So that's the first part. In terms of the second part, yes, it's very easy for somebody to come up with an idea for a device, but to actually solve the problems, they need to know an awful lot about an awful lot. And what generally happens with a small company run by an entrepreneur and a few technologists, they do have some blind spots and areas that they don't know already exists, probably in the offshore oil and gas industry. And so they're spending money learning things that they shouldn't really have to learn. They should just be able to plagiarize it from other sectors. But within our program, we broken it down into subsystems, and it means that we've attracted some of the best companies who already have that knowledge and ability to develop those particular areas, and so they're not having to do this learning. But as you said, in terms of them coming together, well, and those subsystems coming together into an individual WavEC, that is happening, but more by chance than design, because we couldn't set off day one with an idea about what type of wave energy device would succeed, and then picking the various subsystems that are required to feed into that design. It's more by luck and chance within this sort of program that those things are coming together. But some of the technologies that are coming out of our program may go on into other wave energy converters. So that's all good. But
Pedro, I think you have a question.
I have a question. regarding the development of the technology. So a few years ago, and also early 2007, there was lots of funding available for wave energy devices, mostly in UK and in Scotland. There were lots of technologies that did their route, but most of them, they did not succeed. So the first question that I have is, what went wrong? And considering all the amount of money that was available and all the ideas that different type of devices that were available, what was the reason that did not work? And the second question is, nowadays we start to see some, I'll say, promising devices. Few we start seeing again. So my question is, what is going to prevent that happening from again? What are you doing differently? What have you learned in the past? And how can you overcome the issues that we faced in the past? So.
There are a large number of reasons as to why perhaps the devices that were deployed failed. And part of it comes down to funding. As you go up the development path, then you need more money. And if there are technical issues, once you've deployed it into the sea, it then becomes very expensive to solve those problems. It's much easier to solve those problems earlier on in the development process. On a piece of paper, it's very cheap. Once it's actually out in the ocean, something goes wrong, it's very, very expensive. But the deployment of those devices and the learning that was achieved by actually operating those devices offshore was very useful and is useful experience to feed into the future design. So, but the way to avoid it is partly the way we're doing it is structured innovation. It's taking a stage gate approach and getting the best companies in to develop their parts of the technology to reduce the risk. So that's hopefully the way that risk will be reduced and hopefully success in the future. So lots of testing and stage gates.